So we were discussing yesterday one and onto function, and today we will learn these function with more examples, right? So we will go back. What is a one function, right? When every element of the domain is connected to one element only in the image, then we are having a function one. That means every element of domain have only one image, right? And every image in the range is having only one pre-image, right? Then the function is one. And what is onto means what is our codomain means the second set. Whatever the elements are in codomain, all the elements should be in range. In onto function, our codomain is equals to range is equals to codomain. That means all the elements of second set are connected to elements of first set. No elements in the second set is unconnected, so that is onto, right? Now we will be learning it with examples, which function you will say one and which function you will say onto. Okay, one more thing we discussed: if the function is not one, then we say that the function is many one. And if the function is not onto, this we have not discussed, we say that the function is into. Not onto, then into the spellings are INTO. If every element of second set is connected, then we say that the function is onto. If there are few elements which are not connected, the function is not onto. If the function is not onto, we will say that the function is into. Now we will check with the help of examples, right? Show that the function f is a mapping from n to n given by fx is equals to 2x is 1, but not onto. Before this, before taking this function, I would like to take function f of x is equals to x, right? And f is a mapping from n to n. This function first we will discuss. This function, whether this function is 1 and onto. F of x is equals to x means we have one set x, we are mapping it to another set which is f of x. And what is the mapping? F of x is equals to x means it is 1 into x, right? So set all the elements x which take which value? All the natural numbers n, because the first set in the mapping we are saying mapping is from n natural numbers to n natural numbers. So the set will be having 0, no, 1, yes, 2, 3, 4, 5, 6, and so on, right? All natural numbers, it will be up to n natural numbers, right? Then f of x will depend upon x. F of x is not an independent value, it depends upon x. If x is 1, if x is 1, then f of x is 1. If x is 2, then f of x is 2. If x is 3, then f of x is 3. If x is 4, f of x is 4, 5, then f of x is 6, f of x is 6. And if it is n, then f of x will also be n, right? Then 1 is mapped with 1, 2 is mapped with 2, 3 is mapped with 3, 4 is mapped with 4, 5 with 5, 6 with 6, 7 with 7, 8 with 8, and so on, n with n, right? So is this function a 1 function? Yes. because every element is mapped with one element only, right? So this function is 1 1. Is this function onto? Yes, because every element of f of x will be having pre-image, right? आप f of x कुछ भी ले लो, you take f of x as 9, then x 9 will be here. F of x is 30, x will be 30. Every image of f of x is there in x. So f of this function mapping f from n natural number to n natural number given by f of x is equals to x. The function is 1 1 and onto, right? This function is both 1 1 and onto. Now after that we will discuss this example, which is the example of your book. F is a mapping from n natural numbers to n natural numbers. You have to check if the function f of x is 2x, then whether it is 1 1 and onto, right? So we will check. F of x is equals to 2x. We will make two diagrams so it is easy to understand it with help of arrow diagram. Here it will be x. In the second set it will be f of x, and f of x is given by 2x. X can take all n values because f is a mapping from n to n. All natural numbers means x, this all natural numbers mapping 2x. This first n belongs to first left hand side, right, which we are taking x, and this second n after arrow belongs to the right hand side, which is 2x, right? This will take all the values of x, and this set will take all the oval will take all the values of 2x. Now n natural numbers means here it will be 1 2 3 4 5 6. Again it is going up to infinity. And natural numbers, it will be going up to infinity. We cannot check the last number, right? Then f of x is equals to 2x. In the set, elements will be n natural numbers. Elements will be n natural number 1 2 3 4 5 6 7 8 9 and so on infinity. But our mapping is only x to 2x. That means when my x is 1, f of x is 2 when x is 1. F of x is 4, x is 2. F of x is 6 when x is 3. F of x is equals to 8 when x is equals to 4. We are substituting x here. When x is equals to 1, 2 into 1, 2. When x is equals to 2, 2 into 2, 4. When x is equals to 3, 2 into 3, 6. When x is equals to 4, 2 into 4, 8. This way. Now, this is also a set of n natural number. This is also a set of n natural number. We have defined this function. F is a mapping of n natural number to n natural numbers. Then we will check. 1 is going to 1. No. 1 is going to 2. 2 is going to 4. 3 is going to 6. 4 is going to 8. 5 is going to 10. 6 will be going to 12. And so on. This n will be going to 2n, which will also be natural number, and so on up to infinity, right? Will you find somewhere that element 1 or 2 will be element 2 on the right hand side will be having two pre-images? क्या ऐसा हो सकता है कि ये मैनी वन फंक्शन बन जाए कि कोई एक फोर एक ऐसा एलिमेंट है जो 2 को भी बिलोंग करता है या किसी और एलिमेंट को भी बिलोंग करता है? It will not happen. For every x there will be only one f of x. अगर 1 है तो वो सिर्फ और सिर्फ 2 को ही correspond करेगा. अगर 2 है वो सिर्फ और सिर्फ 4 को ही correspond करेगा. 3 will correspond to 6 only. This means for every element in X, there is one and only one element in f of x. और ऐसा भी है कि डोमेन की हर एलिमेंट कनेक्टेड है, डोमेन के जितने भी नेचुरल नंबर्स हैं उनका ट्वाइस दूसरे नेचुरल नंबर के सेट में होगा ही होगा. सो दिस सेट इज 1 1. दिस इज ट्रू that this set is 1 1, but not onto, now this set is not onto. Can you tell me why it is not onto? This is not onto.
Because all the elements are not connected of set B.
Yes, because see the element 1, see the element 3, see the element 5, see the element 7, see the element 9, and so on. Every odd element in the second set having no pre-image, right? One is not, because if you want that one should be connected to any element, that means x should be 1 by 2. If x will be 1 by 2, then f of x will be 2 into 1 by 2 is equals to 1. That means for f of x is equals to 1, x should be 1 by 2. 1 by 2 does not belongs to n natural numbers. Therefore, 1 by 2 does not belongs to x. Therefore, f of x with value 1 will not be having pre-image. Similarly, 3 will not be having pre-image. 5 will not be having pre-image. Therefore, this set is 1 1 but not onto, right? This way we will prove that this function is 1 1. You will write that every odd element in the set f of x is not having pre-image, right? Therefore, this set is not onto. So it is written that f is not onto, as for 1 belongs to n, there does not exist any x in n such that f of x is equals to 2x is equals to 1. So the set is 1 1 and not onto. So if in this question there is any doubt, ask me, only then we will move further. Clear? So we will move next. Okay. Next, the same set f of x is equals to 2x, but we have changed the domain and codomain. Earlier, the domain and codomain was the set n natural numbers to the set n natural number. But right now, the domain and codomain is the a set R of real numbers. So this is a real function, right? Domain is a real set of real numbers. Codomain is the set of real numbers. And we have to prove that the function f of x is equals to 2x is now it is 1 1 as well as onto. But we have to check how, right? F of x is equals to 2x again. Now we will be having two sets, x f of x, and f of x is given by 2x. Now it will be having all real numbers, 0, right? It will be it will be like a number line, right? 0, then 1, then 1 by 2, 1 by 2, half of that, then half of the in between numbers, half of that in between numbers. You know na real numbers, right? All possible numbers that exist on a number line. We will be having all numbers in the real set. So I am taking for example 0, right? Okay. 1 by 2 we take 1 by 2, then we take 1, right? Then we take 3 by 2, then we take 2. So these will be negative. And here I am taking 1 by 2. Even 7 by 8, 1 by 8, 1 by 10, 1 by 30, all numbers will be included. 3 by 2 and 2, say, right? And f of x is 2x is also having 0, minus 1 by 2, and it is minus 1. It is minus 3 by 2, it is minus 2, it is 1 by 2, 1, 3 by 2, then 2, and so on. Now, if I'm taking x is equals to 1, right? X is equals to 1. Then in the other set, my mapping will be with x is equals to 2. If I'm taking x is equals to 1 by 2, then f of x will be 2 into 1 by 2 is equals to 1. So 1 by 2 will be connected to 1, right? If I'm taking x is equals to 0, f of x will be 0. If I'm taking x is equals to 3 by 2, right, x is equals to 3 by 2, so f of x will be 3 by 2 into 2 is equals to 3, so 3 by 2 will be mapped somewhere here with 3. If I'm taking negative values, even then for every element on the left hand side there will be one unique element on the right hand side. So f of f is 1 1. Mathematically we can show f of x1 is equals to f of x2 implies 2x1 is equals to 2x2 implies x1 is equals to x2. F of x1 is equals to f of x2 implies 2x1 is equals to 2x2 implies x1 is equals to x2. If mathematically it happens, then we say that the function is 1 1, but otherwise diagrammatically you must be knowing that every element of x is connected to every other element of fx, and every image have only pre-image, and every element of the domain is connected to only one element in the range, right? Also, given any real number y in R, okay, there exists y by 2 in R such that f of y by 2 is equals to this. We have taken the example that in the right hand side, in the range, you take any element, okay, any element. Say if I'm taking minus 3 by 2, right? And I just want that its pre-image should be there in X. Then it will be there. Minus 3 by 2 means its pre-image will be minus 3 by 4. Minus 3 by 4 will be lying somewhere, right? Minus 3 by 4 will be less than 1. So minus 3 by 4 will also be a real number, right? So if I want to know the pre-image of minus 2, it will be there in X. If I want to have pre-image of any number 18 by 17, right? Its pre-image will be there in X. Yes, it will be there in X. So every f of X will be having a pre-image in X, because now the set is of real numbers. Early in previous example the set was from natural numbers, but now the set is of real number. For every real number on right hand side there will be a real number on the left hand side. That means the function will be on 2, because every number will be having a pre-image. Mathematically we have taken the example, okay, that for every y there exists y by 2 in R such that f of y by 2 is equals to 2 into y by 2 is equals to y. How it is written? We are taking f of x is equals to 2x is equals to y, right? We are writing f of x is equals to y. This implies 2x is equals to y, which implies x is equals to y by 2. We are saying x is pre-image and we want to check whether all the values of x are there, whatever y will be. So yes, whatever y is, that means whatever your range is, we will be having x. If y, I just said, if y is 18 by 17, right, then what will be, if y is 18 by 17, then what will be x? X will be 18 by 34. You put any value of y means any point from the range, you will be getting x. That means it's a pre-image in the domain. Therefore the function is 1 1 and onto. On the set of reals it is 1 1 and onto, but on the set of natural numbers it is 1 1 but not onto. So it not only depend upon what the function is, it also depends what the domain is. The domain and range are very very important, right? So this is about 1 1 and onto in this example. If any doubt you can ask me, otherwise we will move further. Clear? Okay. Then this we will be doing later. First we will be taking question these examples. This is a question from your exercise, question number 2. Check the injectivity. Injectivity means 1 1 and surjectivity means onto of the following functions. Now you see, the function is x square, x square, x square. The function is same, but the domain is set of n natural numbers, set of integers, and set of real numbers, right? We have to check whether the function is 1 1 and onto. We will check one by one. So f of x is equals to x square. For 1 1, right, again we will be proving f of x1 is equals to f of x2, implies x1 square is equals to x2 square, implies x1 is equals to x2. Thus f of x1 is equals to f of x2 implies x1 is equals to x2. Therefore function is 1 1. Now here it is, I have written x1 square is equals to x2 square implies x1 is equals to x2, but otherwise we know that x1 square is equals to x2 square implies x1 is equals to plus minus x2, because if I'm taking x2 is equals to minus 2, minus 2 square is equals to 4, x2 is equals to plus 2 square is also 4, right? So x1 should be plus minus x2, but I have directly written x1 is equals to x2. Why? X1 square is equals to x2 square implies x1 is equals to x2, but I should have written x1 is equals to 1 plus minus x2, but why I have
Because
written,
we are applying the function on natural numbers.
yes, reason is the set is from n natural numbers and negative numbers does not exist. So मेरे सेट में नेगेटिव नंबर तो है ही नहीं. So how can I write x1 is equals to minus x2, right? So minus x2 तो मेरे सेट में है ही नहीं. So I'll be directly writing x1 is equals to x2. Therefore, I have proved that the function is 1 1, right? Now we will check whether the function is onto, right? Okay, just wait. We will be checking whether the function is onto. For this, what will be the steps? We will be following the same steps. F of x is equals to x square is equals to y, right? which implies x square is equals to y, which implies x is equals to root y. I'm not taking negative values again. Okay, plus minus I'm not taking, I'm taking only root y because my mapping is from set n to n. Now, you have to check for every y, x should exist. If for every y, x is what? Pre-image, right? And y is what here? You can say codomain or range, right? Range. You are checking range. Then if for every element y there exists x, then we will say that the set is onto, otherwise the set is not onto. For y is equals to 1, x is equals to 1. For y is equals to 2, x is equals to root 2. Root 2 does not belongs to n. That means when I will be having two sets, one is x, one is f of x is equals to x square, and I will be having a natural numbers 1, 2, 3, 4, 5, 6 and so on, 1, 2, 3, 4, 5, 6 and so on. Then 1 will be connected to 1, 2 will not 2, x is 2, then y will be sorry, y is 2, then x is root 2, then root 2 is not there, the 2 is not connected to any element, 3 is not connected to element, but 4 is connected to 2. Similarly 9 will be connected to 3 and so on, but there will be so many elements which will be having no pre-image, but we have to write at least one element. So the steps to follow is you will be taking f of x is equals to x square is equals to y. Then you will write x in terms of y. Since for y is equals to 2, there is x is equals to root 2 does not belongs to any natural numbers. That means there will be at least one element 2 which will be having no pre-image. Therefore, this function is not on 2. Mapping from n natural numbers to n natural numbers is not onto. This you have to show, because what is onto function? Every element in codomain should have a pre-image, but 2 and 3 are the elements which are not having pre-image. Even 5 and 6 will be the elements which are not having pre-image. Therefore, this function will not be onto. Okay. So this example is clear. So we will be moving to the second example. What if we are taking a set z to z, a set of integers now, then whether the function will be on to 1, 1. Okay. The second, this is second part. F is a mapping from set of integers to set of integers, and the function f of x is equals to x square. Now we will check whether the function is 1, 1. In the set of integers, we take the negative values. What is set of integers?
Set of integers. Yes, ma'am.
0, -1, -2, -3, 1, 2, 3. All the integer values from minus infinity to infinity, right? All the values should be integers only, but we can take positive and negative values. So f of x1 is equals to f of x2 implies x1 square is equals to x2 square, implies, now I will write x1 is equals to plus minus x2, right? So this, okay, this function will be 1 1 or not, this we will check. This function will not be 1 1, right? Because I will be having, with the help of example, we will be doing y. This is x, this is f of x is equals to x square. So I am taking 0, -1, -2, -3, -4, 1, 2, 3, 4, and so on, right? 0, 1, 2, 3, 4, and so on, -1, -2, -3, -4. Now, if f of x is equals to x square, put x is equals to 1. F of x will be 1. Putting x is equals to 0, 0 will be mapped to 0. X is equals to 1, f of x is equals to 1. So 1 is mapped to 1. X is equals to -1, f of x is equals to -1 square, which is 1. So x is equals to -1 is also connected to 1. So 1 is connected to 1. 1 is connected to 1 and -1 is also connected to 1. So many pre-images is having one image. So this function is not 1 1. This function is many 1. In the previous example, when we had taken the set of natural numbers, then we had seen that the function was 1 1. But when we have changed our domain and codomain, the set of integers we have taken, we have seen now the function is not 1 1. It is many 1, right? This is many 1. It's the same way element 2 will be having 2 will be connected to 4 and -2 will also be connected to 4, right? You will be finding so many points, so many pre-images that will be having only one image. Therefore this function is many 1. This function is not 1 1. Now, for checking whether this function is onto, again we will be checking the same way. The process is same. For checking the function is onto, we will be taking f of x is equals to x square. Let us take f of x is equals to y, which implies x square is equals to y, and which implies y is equals to plus, sorry, x we have to represent x square is equals to y, which implies x is equals to plus minus root y. For every y, for every integer y, whatever the elements are there in the second set, x should be available, right? So if I'm take y is equals to 3, y is equals to 2, right? X will be plus minus root 2, which does not belongs to z, right? Because we are taking set of integers only, right? So x, since y is equals to 2 is having no pre-image, therefore the set is not on 2. The set is many 1 and the set is not on 2, because every element should have pre-image, but y is equals to 2 will be having no pre-image. Even y is equals to minus root 2, that will be a imaginary number, right? So this function is not on to. Now you will try for the set of reals. What happen when the set is reals? Then try it for x cube on the set of natural numbers and on the set of integers. Then we will be doing more examples tomorrow. Okay, today we'll be cover up to this. And if you have any doubt, you can ask me, because my next class I have to take at 12. This is clear? 1 1 and on to.
Yes, ma'am.
Okay, ji.
Okay, Ji.
Then you
Thank you,
practice
ma'am.
the question. Okay. All the questions I've taken from NCERT book only. I'm teaching from NCERT only because online book is also available. It will be easy for you if you are not having any book at home. Okay.
Okay, ma'am.
Okay, Ji. Then bye bye.
Thank you, ma'am.
I will be asking you only tomorrow. It will be interactive class, and I will ask you people only. Tell me what is 1-1, what is on 2. Okay. So come prepared. Bye bye.